Hello and good morning everyone, and thank you for joining our webinar today. That is going to be focusing on HPE Cloud Volumes. So we're delighted to be joined by Steve Walker from HPE, who's going to be presenting the webinar with you today. But just before I pass over to Steve, I'm just going to go through some housekeeping details with you all really quickly. So you are muted throughout the webinar today, but there'll be a Q&A session at the end. So if you do have any questions, just pop them in the questions box, which is just the right-hand side of your screen, and I'll read those out for Steve at the end of the webinar. We're also recording the webinar today, so I'll send you a link to the recording tomorrow afternoon, or if I've got time, I'll try and do it today. And there are a few questions at the end, so if you would like to request any further information, or if you've got any feedback for us, please do pop that in there and we will be in touch. Okay, so I'm now going to pass you over to Steve, who's going to be presenting the webinar for you today.
Thanks, Amy. Thanks, everyone. And I'm just going to share my screen, so hopefully everyone can see what I'm sharing.
Yep.
So that's good, thank you. So just as an introduction, so my role at HPE, I'm a pre-sales manager in the storage division in the UK, and I've got a roughly about 20 minutes worth of content to share around HPE's cloud data services, which includes HPE Cloud Volumes. So we'll go through the slides, and as I say, any questions, just please type them in the Q&A, and I'll cover them at the end of the presentation. So just from a hybrid cloud experience, really, what's key is what we see today is that there is a hyper-connected world where we're seeing increasing amounts of data being generated and new value from data. And obviously, from a point of businesses creating new ways of using that data, cloud is fundamental to be able to drive that use of information. And the issue there from an administrator is that because of the way that we've got all of these multi-cloud providers, whether it be on-prem, up in the cloud, it can be quite a difficulty to manage infrastructure across all of these domains and data effectively. Also, the pressures of managing cost, the sprawl of VMs, and also the pressure of having to try to manage applications now from a traditional way now into the world of how applications are managed in cloud native ways. And you see that you've got the way that IT ops are looking at this bimodal world in terms of the traditional applications, the VMware, the Microsoft, the three-tier applications that sit on-prem. And then you then have these more cloud native applications in mode 2, the likes of Docker, Kubernetes, all different applications that clearly are being built to work clearly in cloud environments, the likes of AWS and Azure and Google. What's interesting though is from a point of enterprises, it's certain aspects that when you go across both of these modes, having availability is crucial. Having consistent performance so that you know that when the things are delivered, they're done at the right cost, at the right speed. And also the ability to move data. So having data that is in a hybrid world, that mobility is crucial, and that portability to be able to provision data and applications with the data associated in the right place. And as HPE, we really see that it's crucial that intelligence can drive the decision making based on how applications and workloads are best suited and where they're best suited to run. So it could be the case that there's a certain application that it would make sense to go into the public cloud for different reasons, whether it's the bursting ability, whether it's the cost, whether it's the reach that you have with different cloud providers. Or it could be different other reasons that could drive it to be in an on-prem solution. Is it mission critical? Does it need to be local to that particular set of users? Is it to do with providing a more efficient on-prem solution that's going to drive general applications and keep costs down? These are all decisions that can be made human, but really if you can use different aspects of intelligence and machine learning, can really help with understanding where those workloads are best suited today and obviously going forward into the future. So specifically with HPE Cloud Volumes, what we've delivered is the ability to provide a service of storage that has the enterprise features of a traditional on-prem solution, but being able to be consumed in any of the providers such as AWS, Microsoft Azure, and soon to be released is with Google Cloud. And because it's essentially off those providers, we can provide data mobility in terms of on-prem up to this service, and then also unpin and pin it to different providers based on the actual use cases that are being required. The other part is because it's using HPE's technology around InfoSight, it gives us real insight to how the machine learning and automation that we have with InfoSight can give clear visibility on how the data is in that particular service. So as components that we have, because I've mentioned it is an enterprise storage array, we have certain features that are available as part of that service. So we have things that can really help with regards to copy data management. So if there's particular data sets, we can do very, very efficient, fast snapshotting and provision them out for different use cases for cloning, say for databases, which could be ideal for test and dev, or for business intelligence, where you want to have multiple copies in different locations for serving to different environments. We provide encryption at rest, which allows us to give that security that the data is secured in the cloud. Essentially, we have an option of having a central admin portal, which allows you to provision to all three cloud providers. You create the volume, you give it the amount of IOPS that you needed, capacity, and essentially then point it to which provider, and then it'll then be served to, if it's AWS, the EC2 instances that are in AWS, and then the data is then served from HPE, and the equivalent for Azure and Google. Other part is that because of the way that we automate our support experience, if there is a challenge with the particular Cloud Volumes, you can, within a minute, be through to a level 3 technical support engineer who can troubleshoot and start to look at where there is potential issues with that particular volume and help with escalating that particular issue. It is really a truly multi-cloud service. The fact that day one you can serve data to AWS, and then you can then unpin it from that service in AWS and move it to Azure, and there's been no data movement at all. So that is an instant way of using multi-cloud, and I'll show examples of where it really helps with providing that data that can be moved between cloud providers in an efficient way. And what's crucial, especially with cloud workloads, is having an ability to automate, whether that through API, whether it be through CLI, different ways such as Python, and even now with Docker and Kubernetes, being able to drive that through an API is crucial, especially if you're looking at a CI/CD pipeline. It really helps with driving those efficiencies and speed of access. So the key part of the Cloud Volume service is it is a physical service that we have close to these regions. So today we have it in US West, we have it in US East, and we've just recently announced it in the UK, in Europe, and it's soon to be released in Ireland as well. And the plan is to provide that in other geographical expansion. But it is the fact that we do have the physical kit there. It's not a virtual instance that we place in those providers, and it gives us clear ways of being able to provide a different level of service by doing it this way. So we just recently announced as well a partnership with Google Cloud with the Anthos technology, which will work with Cloud Volumes. So what we can do is provide customers that on-prem experience of the GCP management and have it on either, in this case, we've got it on ProLiant and Nimble storage, which can then work directly with HPE Cloud Volumes. And then as that everything as a service experience, it'll then allow applications to be run either on-prem or then be moved to a multi-cloud provider, whether it be Google's own provider or even AWS and Azure when Google have that enabled in the Anthos technology. Another key area is around containers. So what we have is we have support for a broad part of the container ecosystem. So we support Docker as part of our integration with Docker, both from Windows and Linux. We also support Kubernetes as part of our Flex Volume plugin, which allows us to then provision persistent storage into a Kubernetes environment. And very similar with the Mesosphere, we have the Docker Volume plugin, which allows us to plumb in via an API container persistent storage so that we can then deliver that either with a Nimble array, even with our 3-part technology, and then as well into the cloud with the HPE Cloud Volumes. Interestingly, what we've done with Cloud Volumes and with our Nimble technology is deliver a really app-centric way of how we can manage applications. So in this example, we've got an Oracle database. And if you look at the checks on the right-hand side, it's really asking for guaranteed IOPS. We want to deliver some efficiencies, and we also want to encrypt that data with a set of local protection and move the backups off to a cloud service. So all of this can be delivered as part of the provisioning of the application, and this allows us to then place that application, in this case with Oracle, on our all-flash array in this scenario, and then be able to then replicate that data natively up to the HPE Cloud Volumes. Second scenario, though, is that in this example, we've got a set of contained applications with some persistent storage. We then provision based on the variables that are set in that YAML file for Kubernetes, and that will then provision based on that requirement. So in this case, we are provisioning some persistent storage from the public cloud, and then we're then replicating it back on-prem, in this case to our hybrid flash, which provides a lower cost from a point of storage, but can still deliver that near flash experience. So the key part here, though, is the flexibility of choice, which could be today, this is the requirement, and then over time, it could be the case that the workloads need to be moved to on-prem, either on a hybrid flash or an all-flash, and this is where we can really help with that data mobility between the two within a hybrid cloud environment. So I mentioned before about, with cloud native applications, we see a real drive to have this, a large portion of it being automated using things around the CI and CD pipelines, and having an ability to use API calls. If you've got an application that is being delivered via a development team, they're going to be placing that environment probably in source control repository. It could be GitHub, it could be a similar equivalent, and then that could then flow from the whole build, ship, run through the whole process of the CI/CD pipeline in terms of our API calls, working with the likes of Jenkins, Maven. And what's key around those applications is having the data to be able to make that development environment as consistent with production. And this is where Cloud Volume can really help, where you have your hybrid world where your data is held on-prem, for example, you're then using the cloud in terms of Google, Azure, or AWS, and we can then serve the data through that life cycle of the CI/CD pipeline. So here's a different scenarios that you can see with regards to the cloud volume. So we have the service close enough to both AWS, Google, and Azure, but it is actually separate from those data centers. So in this example, we create a volume of an environment. This could be a particular database that we have, and we then serve it into this particular cloud volume provider. The compute choice is there. So that is one setup where we have the volume provisioned up to the compute in a provider. We then create an efficient, fast clone of that data. So this is where if it's a 10 terabyte database, we've then literally instantly created a 10 terabyte virtual copy, and that's taken 0 space, and the time is obviously instantaneous. So this is where we can then provision off a fast clone of that snapshot and mount it to a completely different set of compute. This could be, use cases could really be from a point of test and dev or business intelligence. You have that data, you can now start to serve virtual copies very quickly and really efficiently on the storage footprint. But because we're separate from the providers, it's very easy for us to create another clone and then provision this to a completely different provider. It could be AWS on the left-hand side, and now we then serve another clone to Azure. And in this case, we're setting it up to a failover cluster. We've now provisioned that storage to that provider, which allows us to get even more value from that data in the HPE Cloud Volumes. It then allows us to then easily, with a few clicks, just unmount it from the right-hand side cloud provider and then mount it to the one on the left-hand side. And that 10 terabyte example, there's not been any data movement whatsoever. It's literally just mounting it to the compute on the left-hand side. So this can be done via a portal. It's all done on a pay-as-you-go way, which you'd expect being on a cloud provider. And it gives the ability to on-ramp, move between cloud providers from either a DR to cloud or test and dev, or whichever use case you can deliver. It will allow you to do that. And as well as the fact that I've mentioned already, it has these enterprise grade features that you'd expect from having on a primary storage system. The fact that we've got 6 nines availability, we deliver that in this cloud provider with HPE Cloud Volumes in terms of that availability, which is completely different to the SLAs that you typically see when serving block storage in the hyperscale providers. So I'm going to give you a 5-minute demonstration here. On this example, we've got a demonstration for Google Cloud Platform with Anthos. So here we've got a demonstration that shows us moving from a particular provider in the cloud in AWS, and then showing the power of being able to do this from the Anthos platform and deliver this to a different area in terms of moving it to Google. So from the visibility of this demonstration, we have this environment, which is where we've got the Cloud Volumes provisioned. And in this case, we've got a simple application that's being created. So just in this example, you can see it's running in AWS. And we have these 2 workloads that have been created. We've got a database, and then we've got a virtual ASP web server that's pointing to that database. And here we can see that there is, in this particular environment, we have persistent storage, which is underpinned by the HPE Cloud Volumes. So as part of the Kubernetes engine, we can see that there's a volume that's being configured. It's a persistent volume that is set with a class of HPE Cloud Volumes SQL class. And this is the volume name that we see in the Google Cloud Platform plus when you search in the Cloud Volumes portal, you can see exactly what the volume is associated in size, and also at the moment it's pinned to the AWS provider. So as part of this, now we then look at the YAML file, and we can see that we've got the information that's been configured in the parameters to talk via API to the Cloud Volumes system. And now we're going to add some more content to the application. So just basically, we're going to move this complete data from AWS to Google, and clearly it's stated in that record here in this database. Now the demonstration now, what we're going to do is via the Kubernetes kubectl command, delete the pod, the service, and the deployment of that application that is currently in AWS. So this is where the script will look at all those different components and delete those services. We also then delete the persistent volume claim in the Kubernetes environment. And clearly now you can see that that service is no longer available in AWS. So now it's a case of us now pointing this service into the GCP demo. So you can see here we've got 3 nodes available in this environment. And we can now start to create the service in the Google environment. So the storage is now created. You can now see the class of, and we will import the volume that was in the AWS environment now into this Google service. So now we can see that we've got the service configured for the storage, and now it's a matter of just deploying that particular service for both the database and the web server. And we can see now that the pods are currently building out that configuration based on the files that have been deployed in there. And now you can see clearly that we've got the database and the web service, but now running on the Google Cloud Platform instead of AWS. And then when we look at the load balancer, we can then connect to that endpoint. And when we hit the endpoint, we can now see that we've got that web application plus the record that we added previously. So in summary, really the idea is that with Google Cloud Volumes, it's all about simplicity and complementing the services that you have in AWS, Azure, and Google with serving data to those environments. It's incredibly flexible and dynamic in being able to move between cloud providers, move data on the fly back to the hybrid on-prem solution. And it's incredibly secure in terms of our encryption, the multi-tenancy, and the data features that we have are the fact that we've got this highly available 6.9 solution, but also the tight integration with applications such as Docker, allowing things around backup and protection, and also cloning that data, all delivered as a service, is a really exciting time, I feel, for us to help businesses move data between the hybrid cloud. So that was the slides I did for today. Hope that was useful. And Amy, I'm not sure if there's any questions at all in the Q&A.
Brilliant, thanks, Steve. So yeah, if you do have any questions at all, there is a questions box just at the right-hand side of your screen in the control panel. If you pop those in there, I'll read those out. Let's just see if we've had any come through. Okay, nothing yet. So we'll just wait a minute or so, see if any come through. Alternatively, there is our email on the screen there if you'd like to submit any outside of the webinar. Okay, so I don't think we've got any questions today. So thank you everyone so much for joining and taking the time out of your busy days to join the webinar today. And thank you so much, Steve, for presenting as well. As mentioned at the beginning, there is a feedback form at the end. So if you would like any information or if you'd like to request a callback, please do pop that in there and we'll get back to you. And I will send you all a link to the slides this afternoon or tomorrow morning. So thanks again, everyone, for joining and enjoy the rest of your day today. Thank you.
Cheers now, bye.